Good morning, welcome in. 6:30, Friday, July 23rd. For another safety focus of the week. This week's code item is to be prompt, start on time, work, appointments, projects, etc. That's our goal, is to try to really start when we say we're going to start. Again, it doesn't hurt to throw in a message if you're running late. Let's not speed where we're getting to. Let's just good communication and really try to good communication to make sure we're starting on time and good communication on each other's schedules. This week, just wanted to kind of highlight confined space. We do have a confined space program. I think it's important that everybody knows that. It's in our corporate health and safety manual. Our program is pretty basic, follows the OSHA regulations, but for the most part, it's everyone needs to identify what a confined space is, and a confined space is large enough for an employee to enter. It has limited means of entry or exit and is not designated for continuous occupancy. So mostly for us, it's a lot of our catch basins, sewer manholes, culverts, things like that. So one of the biggest problems with confined space is the two different hazards, the physical hazard and the atmospheric hazard. So the physical hazard that we have to deal with is falls or caught in between. These confined spaces are sometimes very small, but also it's the means of egress getting in and out is really the danger hazard with a physical hazard. And secondly is that atmospheric hazard. And these are those hazards that our senses can't detect. We can't see it, can't smell it. Well, you can with hydrogen sulfide or flammable material vapors, but it's that big one is that oxygen deficiency. That's where a lot of the fatalities happen in a confined space. Someone enters a space that has oxygen deficiency, and then within maybe 15 minutes or so, they lose unconsciousness and they pass. So we really always want to make sure that we have a 4-gas meter that's calibrated on our sites before we even start to enter a space. That we always test that space with our 4-gas meter, making sure that we don't have oxygen deficiency. Our carbon monoxide levels are less than 50. Our LEL, which is our lower explosive limit, is under 10%, and our hydrogen sulfide reads less than 10 ppms. If that is the case, then we will be safe to enter that space, and we want to make sure that we always have a retrieval system, a blower, the David system or the 3-way retrieval system to make sure that we can get in and out of these spaces properly. So just some things to remind is just try to call ahead. All the blowers, retrieval system, harness, and the 4-gas meter is all located in health and safety, mixed bag between Elliott in the tool crib and in the Connex out back. And also the confined space forms are now available in Teams in the supervisor foreman's channel. Hit the More tab, and then you'll see it right there on the underneath the More tab. You'll see a confined space form. It's a really quick form to fill out, place to record your air readings, and making sure that you're kind of following all the proper safe work practices to conduct your confined space. Again, health and safety is always here to help, just for the initial setup or just a quick overview when we're doing a confined space on a project. So please let us know, ahead of time. We do have 3 meters, so we can only do 3 confined spaces at once. So make sure we're well coordinated ahead of time, making sure we can provide you with all the right tools and resources to do your confined space. So try to plan ahead anytime you're getting ready to do some confined space work. That's really all I have. A quick hitter today, just a review. So with that said, I'll pass it over to Ken.
Thanks, Matt. Hey, could you just re-summarize the 4 gases and their limits? Because I don't think your slide really showed that as you talked about it.
So yeah, the oxygen, we need to be between 19, or actually it's 18.5 and 23.5, in that range. It's a percentage of oxygen to argon. And I'm drawing a blank with the other type of air, ambient air, but biggest thing is that window between 18.5 and 23.5 is where we want to be. 20.0 is perfect. That's where we like to see. That's the kind of ambient air that we see now. 0 to 50 parts per million on the carbon monoxide. Anything over 50 for an 8-hour day, we are exceeding that threshold, and we need to, come up with some engineering controls or modified into some PPE. Less than 10% of our lower exposure limit, and it's just a percentage because we don't know why. Usually it's a flammable, such as like gasoline is what it's picking out, methane gas. So 0 to 10%, we want to be in that range. Love to see 0, even if you see 1 or 2, that it could be a dangerous situation there. So we really want to make sure that's mostly 0. That's why we want to purge that space with fresh air. And the last is hydrogen sulfide, and we like to see under 10 parts per million on the hydrogen sulfide. Anything less than that, anything over 10 now becomes kind of a dangerous situation. We need to modify that space to get safer. Usually, again, just purging it with fresh air is the best method.
Okay. Hey, Matt, are you sure it's 18.5 or is it 19.5 to 23.5? Just don't want to put the wrong info out there. It used to be 19.5 to 23.5, and that was the OSHA 1910 134, I think it was. I just want to make sure people have the right info.
I'll have to get back. I believe it's 18.5, but I could be incorrect.
Yeah, well, it probably tells you on the meter too, right?
The meter will beep at you. All of our meters are calibrated and all have alerts. I want to say it's 18.5 because of the 20.9 is kind of that mid-range, and that's what we like to see. But I'll get back to everybody on that one.
Yep. Okay, thanks, Matt. So I'll take over with my screen. Okay, can you see my screen?
We can.
Okay, good. So no new announcements this week. And just a recap on the ECI Primary Care Wellness Program with Champlain Medical and Urgent Care. So there's a link here to the program, and I want to summarize as we go over the next few weeks, highlight different sections. I'm going to start with the goals, which is the first part. It's to have a healthy, productive, and happy workforce, to provide employees with access to basic health care, and to reward employees with the full benefits of the program if they participate in a meaningful way to achieve good health. And you can read more about it by clicking the link. You can also contact Champlain Medical directly right away, and they'll set you up with an appointment and get you started in the program. For a weather outlook, we've certainly had a little bit of rain over the last couple weeks, and I feel caught up, but I'm sure that they're probably still classifying us as a moderate drought at this point. So a little more probably wouldn't hurt, but we don't want it to affect our jobs at this point because it's been wet over the last couple weeks, and I'd like to see the sun, which it looks like it'll be that case for a while. It's still summer, so it's still a chance of showers, but nothing extreme here. So the COVID policies, oops, my correction of this week's vaccinated got messed up there. It should have been 83.9 or something like 83.9. And when I corrected it, it didn't all save. So anyway, we have the same restrictions, and which is a reduction and elimination of restrictions, but some cautions about wearing masks if you're susceptible, and to report all illnesses to and close contact to our safety department. If you haven't been vaccinated, please watch the YouTube. I have a link here to Dr. Mark Levine, the Vermont Commissioner of Health, who we've all seen, on TV and also at the weekly governors, or whatever the frequency now is for the governor's press conferences, and he gives a pretty good discussion on it in that YouTube link. And then for the project of the week, I'm going to turn it over to Ben McKinney. Ben, do you want me to continue with the screen, or do you want to take over?
Yeah, Ken, if you don't mind scrolling,
I don't mind.
I'll read it. So we're contracted with VTrans to replace the multiplate carrying the Alder Brook underneath 117 in Essex. The project's located just on the Richmond side of the final off-ramp exit where the circ ends at 117. And the invert of the existing culvert was so rotten that it actually buckled and resulting in soil loss and sinkholes over the structure underneath the roadbed. In 2013, it become pretty bad pretty quick. So VTrans let an emergency contract out to put precast footings with 2-foot thick pre-stressed post-tension slab beams over the structure. So as that material came up through the invert of the pipe and washed down the brook, and they got more and more loss in the roadbed, the road could span over that. And in fact, when we got to that phase and demoed that out, there was a good 4 or 5 feet where I'd sunk. So the new structure is a 32-foot clear span rigid frame, precast rigid frame supported by cast in place pile caps. Each pile cap is supported by 12 HP 1274s, driven approximately 50 feet below the cap into glacial till. This project's phased so that two-way traffic, a lane in each direction, can be maintained during the work. Route 117 is pretty wide in this spot, so to keep both those lanes while we build it half at a time, take down half the old structure, build half the new structure, and then swap it over is easier in some locations. No temporary bridges or major fills required, but like with most phase construction, we do need excavation support to maintain that full width 2-lane roadway. For our plan for excavation support was kind of a hybrid model. We used sheet piling, soldier pile and lagging, shotcrete soil nails, tiebacks, dead man anchors, and now in phase 2, a tied back waste block wall. It's kind of a neat system using a lot of different tools that we've got in our toolbox. We opted to self-perform the crane work on the project. We used our TCC 750 or our 138 HSL lattice boom crawler for most of the work. And for the slab demo and the precast direction, we actually used both machines in tandem thick configuration. Normally on big, heavy, long span, rigid frame and box culvert construction like this, people have a big hydro from a crane service come in and set it. But it worked out well for us this year to do it ourselves. The new structure's on alignment, meaning the path of the brook doesn't actually change, which can be a challenge with bypass, especially with 4-sided boxes. The 3-sided box kind of lends itself to this. And same with being on pile caps. When you're not on pile caps, usually the state, I guess bridge code or bridge design manual would require the substructure to be 6 feet down below the channel of the brook for scour. Being on pile caps lets you get the pile caps, the substructures, high and dry to some degree, although maybe not quite high and dry enough. But we were able to maintain the brook on alignment for most of the project. There are certain phases like channel construction itself, some excavation, removal of the old culvert where we did bypass the brook. So we used an upstream cofferdam to keep the water back, in a bypass pumping system, downstream cofferdam to keep Winooski River backwater and brook backwater from coming at us. And we used a 16-inch HDPE line underneath 117 installed by horizontal directional drill methods, and 2 diesel pumps working in tandem when needed to completely bypass the brook around our work under 117 and out downstream. Project is now in its second phase of construction, and we're slated to wrap things up in fall. So you can see there a profile view of the new structure. It was a concept. We actually got to pick what we wanted to do between they're showing, they're kind of showing what looks like more of a buried metal arch structure, which was an option for us to use. We went with a precast rigid frame because of the speed to use this structure. We would have had a lot of really small concrete coping pours around the metal. and MSE wing walls and cast in place head walls. And with the cure times, that would have really killed our schedule. So we opted for a rigid frame, and I think we're happy we did. It's gone pretty smooth. You can see the old structure there. You can see where the bottom's just buckling up and they're getting soil loss from underneath. And you can even kind of see just in that short section where it's exposed, you can see where that culvert's in really bad shape and dropping pretty badly. There's us during phase one. I'm using the excavator to break that chemical or concrete grout bond between the void, or not, they're not voided sub, the solid slab pre-stressed bridge components that were put there in emergency. And a tandem picking those slab pieces off onto a flatbed. We actually saved this, quite a bit of value in those bridge slabs. And it was honestly faster to just lift them away than to demo in place and have a bunch of rubble and steel. Looks like another tandem pick there. I can't see if that's, I was thinking that's demo.
Beams. Those are the beams.
Yep. There's our SOE
Someone took a
system.
picture of me, so I had to leave it in here. Dale and myself there.
Putting Kenny, we didn't make Kenny run the grout plant that day, but we did put him to work.
Yeah.
Just welding some sleeves for the tiebacks in the first phase of SOE.
Yep.
Get drilling our tiebacks.
Great shot of the crew. Benny's still there?
Yeah, I'm here.
Okay.
Yep,
Your screen went blank. I didn't see it for a moment, but this is vibrating the piles in. We did drive them with a diesel hammer, and we don't have a good picture of the diesel hammer driving.
Basically, no rock here, but some really dense soil, which is always kind of raises some questions on where you're actually going to get refusal, which is, determined by dynamic load testing with the diesel hammer. But what we do for speed reasons is we get them as far as we can with the vibro before we switch over to the diesel hammer. But we had quite a bit of diesel driving. It wasn't just to test them on this job. We actually had to do some production diesel hammer driving because we were in that really, really dense soil, but not at capacity, which is determined by a certain amount of energy that the diesel hammer, will get a certain amount of resistance, I guess. There's Pat helping us out with some welding. There's pile cap construction with the old pipe all uncovered and still in service. There's precast direction. You can see the tires. So they ship the rigid frame sections in the wrong orientation. So we have to trip them. So I'm sure other people have done tandem trips before. It was definitely our first, but it went pretty smooth. A lot of planning. Setting the structure. One nice thing about the pile cap, it adds time compared to a conventional box, but to have a perfect concrete grade versus messing around with, crushed stone and luan and shimming and pulling it out and getting it and putting it back, to set precast on a pile cap is pretty slick.
Mm-hmm.
There's the T-walls. It's been a long time since we've built T-walls here. I think that's a good system. That's technically an MSE system. So it's just these thin shells with these T's that go back and shear keys that lock the keys together. And it's a form of MSE. Pretty fast.
Yep.
And there's the precast head wall with the precast T-walls, wing walls.
Looks pretty nice, doesn't it?
Yeah, it's a good looking bridge.
Yep. And that's from yesterday.
On to phase two. You can see our waste block SOE there. I'm holding the road back, and sheets and no pipe.
Right, so we had to have an overlap on that phase interface between the south side done first and this north side.
Yeah, the overlap
Yep.
is achieved when we get to that point. We'll actually have a couple big steel plates that actually butt up against the culvert itself to open up that joint, so we can actually make up that joint. We had thought about a two-sided cofferdam, but it's going to be pretty slick to just put some heavy plates in there
Yep.
that go from our sheets back a little further than it is now to the structure that's already built. That'll retain the soil, but open up that joint to make up.
Yeah, that's all in that phasing SOE stuff you were talking about. It's you always have to think to this level of the step of the work. For some reason, I got two photos in there. I meant to have a picture of the road surface, but we don't have that. So we'll move on to the photo archive, and that's the Harvey's Bridge at the Ethan Allen Firing Range back in January 2014, driving H-piles here. So kind of the same type of project, very similar with piles, and that was a precast bridge installed after. Okay, thanks, Ben, and thanks, Matt. We'll catch you guys later today, and everybody be safe out there, and have a good weekend and all that. So, Matt, you still there?
I am.
All right,
just
I'll turn it back to you
Yep. Thanks, Ken.
for closeout. All right, good. Talk to you later.
Appreciate it. Just one little thing, just want to clarify from earlier, it is 19.5, so Mr. Dow was right.
Okay.
19.5 between 23.5. You can see it here. That's our air testing readings on the confined space. Again, the meters will beep when conditions change. So with that said, if you watched it in a group setting, please just send me the people that you watched it with, just so we can have good attendance for our training attendance list for this morning's safety meeting. So with that said, let's be safe. Thanks all for joining us. And if you missed it, we will be uploading and recording or uploading our recording to YouTube here shortly for the ones that missed it. So
Sounds
be
good.
safe today. Thank you.
Thanks. Bye.